Alright, welcome back. In the previous two videos we looked at integrated rate laws, a first order one and a second order one, and with the same situation with a concentration of A declining from 0.6 molar to 0.2 molar in 45 seconds, we ultimately calculated the two rate constants. Alright? And they were drastically different. You can see that right here. This is the first order rate constant, this is the second order. Now what we're going to do is, if given this data, it was experimentally determined that when the concentration of A was 0.8 molar, the observed rate was 0.02 molar per second. What is the reactions mechanism, first or second order, and how do you know? So what we're going to do here is we are going to calculate the rate of the reactions using the rate laws and the corresponding rate constants. Alright, so back over here. Alright, so what do we know? Well, we need to write the rate laws. For a first order reaction, if we assume that, given this problem where we have concentrations of A, the rate is going to be equal to K times the concentration of A. And that's for a first order reaction. For a second order, its rate is equal to K. I'll put a 1 here for first order. This is 2 for second order. But this is going to be times the concentration of A squared. Alright. So now what we need to do is just plug the numbers in. So this is going to be the rate of a first order reaction. So it's going to be the rate constant times the concentration of A that they gave us, which is 0.8 molar. Alright. So it's going to be 0.0244 per second times 0.800 molar. Let's figure out what that rate is. So it's going to be 0.0244 times 0.8. And I got that this rate is approximately 0.01952 molar per second. Alright? Now let's do the same thing for the second order rate. So second order rate is going to be equal to the second order rate constant, which is 0.0741, that's inverse molar inverse second. And this is going to be times the concentration of A squared. Concentration of A is 0.800 molar squared. And that's going to give us the second order rate. So it's going to be 0.0741 times the quantity 0.8 squared. And I got that the rate here is about 0.0474 molar per second. Alright, what is the experimental rate? The experimental rate was 0.200 molar per second. Alright, so what I'm going to do is I'm going to look at these two rates. Alright, and I'm going to say, assuming it's either first or second order, if it was known it was either one of these, which one of these mechanisms is it most likely to be, first or second order? Well, you look at the first order and you say 0.1952, that's pretty close to 0.2. But 0.0474, that's over twice the observed rate. The observed rate was 0.2, and this is over twice that. In fact, this is almost 2.5 times this, okay? But this one's really close. So based on the data, based only on the data that I have, I might say that this is probably a first order reaction. Okay, this is probably a first order reaction. Because since the only reactant is A, the rate seems to vary linearly with A, not on its square or anything like that. So I might say because the rate is close to the experimental rate, it's first order. And this brings up an important point when you're trying to figure out mechanisms. This is one way you do it. Okay? Whenever you predict a mechanism, you can never, with 100% certainty, determine a mechanism. You can't prove a mechanism. Two things: you can only disprove a mechanism, and you can only say that it fits the data. And I would say, based on this data right here, this observed rate, 0.2 molar, is really close to the theoretical rate for a first order reaction. So I would probably tend to say that the first order reaction fits this data. Okay? There's not a lot of error in this. I would say this is most likely first order. And given only this information, we would say it's a first order reaction. However, we can never, without a shadow of a doubt, prove that it's first order. We can only disprove it. Okay? But based on the data, I would say it's first order. So the key here is you can never prove a mechanism. you can only say it fits the data, and you can only disprove it. So hopefully that makes a little bit of sense. All right, so these were 3 videos on dealing with integrated rate laws and sort of predicting mechanisms. All right, so make sure to like this video and subscribe to the channel for future videos and notifications. Thank you very much.